Yeah, so the topic of security is pretty hot. If you saw Lakshmi Sharma from Google's presentation this morning, you saw that the #1 issue with moving to the cloud is security. So given that SD-WAN is so hot for creating VPNs and reaching the cloud, gotta get from the speaker here, the issue of security becomes very important. So I'm going to talk a little bit about the construction of SD-WAN and why it should be virtualized, because that can help build the service chains that Sue White from Netcracker was talking about earlier. But when you do that, you're increasing the attack surfaces. How then can you get the benefits of SD-WAN and yet address those attack surfaces that you've created? So we'll talk a little bit about some very specific solutions for doing that. So first, in terms of what is SD-WAN, we've seen this before, and there's a whole bunch of features that can potentially be in SD-WAN. And what you're seeing as a result of that is different players are stronger in one versus the other. I've got a slide coming up next that shows the different SD-WAN suppliers that the operators have deployed. But one thing that you see in pretty much all of these are routing and tunneling engines and firewall and security. And the reasons for those are that that's the fundamentals. But other functions like hybrid WAN or QoS, WAN optimization may be add-ons. What's really interesting about this slide is that it shows how many different SD-WAN vendors are out there and how many of them are being selected by different operators. Now, we within ADVA work with just about all these. Nav from Silver Peak is going to be up next, and we do a lot of work with them. But different operators have picked different ones. And so this points out a couple of really interesting things. First, that if you're an operator looking to deploy, you've got a lot of choices, and so in some sense there's a lot of risk. The other thing is that just about all of these deployments today are based on appliances. So here we are in the world of NFV and zero touch and automation, and we're putting boxes on customer prem. So that does not meet the strategic goal of becoming more cloud-centric. So our view is that SD-WAN should be deployed, but it should be deployed as software in a cloud-native environment. So let's look a little bit about the transition from SD-WAN. So first we started with toasters. I really like this image of an appliance. That's a really groovy 50 style toaster, but it does signify that deploying appliances is old-fashioned. I mean, we were trying to get away from truck rolls. We're trying to get away from associating a service with an appliance and go to services being associated with software so we can innovate at the speed of software. So the next step is going from an appliance to a bit of software running on a standard server, but in a bare metal fashion. And what we mean by that is the application owns the server. That's the only thing you can do on there. So when we talk about trying to build a sophisticated service chain, no, can't do that. What we really want to do is be able to get to a mode where we're deploying a standard server with standard NFVI infrastructure, hardware and software, and then be able to deploy whatever SD-WAN supplier makes the most sense, and then potentially tie in other applications. We see a lot of interest in coupling SD-WAN with, say, a firewall or some other security solution so you can get a best of breed. But that only works if you have this open environment. Now, as I said before, there's a problem. Before we get to the problem, let's talk about the benefits of this approach. The whole point of going to NFV is to get the benefits of the cloud. To be able to have open systems that are multi-vendor, to be able to innovate at the speed of software, so we can select best-of-breed hardware, best-of-breed software that are decoupled, and that we can build these service chains on demand. What we're seeing is that our customers are able to drive these innovative services not based on cost reductions, not based on reducing staff, but being able to do things they couldn't do before. And specifically, being able to build these sophisticated service chains that are deployed on demand under user control. So, good stuff, right? Well, the problem is that when we move from a monolith to this system built from multi-vendor components, we've introduced more complexity. We've introduced more attack surfaces. And we've got a lot more APIs. So the question is, how can we get the benefits of this multi-vendor open system for deploying SD-WAN as part of an overall cloud-centric offering and address the drawbacks of a multi-vendor system? And the answer is simple but hard. I like to characterize some things as things you know intellectually, like if you want to lose weight, you eat less. It's simple but hard. You want to get in shape, you got to exercise. Simple but hard. What we need for increasing security is a systematic approach with security at every layer. Now, this is not rocket science. If you thought about it, you'd figure this out for yourself, but it's hard to do in practice because it takes some discipline. What I'm going to share for the rest of this presentation is some of what we're seeing as the best practices for implementing security at all of these layers. And to support this presentation, which will be available online, I published a blog today talking about multi-layer security. And if for no other reason, you should look at it because I got a really nice picture of a layer cake that my marketing staff found. So first of all, at the networking and physical layer. So there's a number of aspects here, but it starts with the network itself. One of the things that we've seen is that when you apply data center type technologies like Open vSwitch, they may not be adequate for securing networking out in the network. So what we recommend is the ability to support Carrier Ethernet type networking constructs such as ELAN, eTree, as well as VRFs to separate traffic. Now again, this is standard practice, but what we need to do is bring these standard practices into the virtualized infrastructure. Management network tying in using technologies like IKE, being able to provide internal firewall protection between the management network and the applications that are running. And then on the physical side, being able to support a wide range of servers, including some that have additional capabilities such as RF shielding or tamper prevention if you're looking to get some type of sophisticated certification like FIPS. All right, next at the virtualization layer. There's been a lot of talk about containers. We do see applications for containers, but today we believe that there are security benefits to running VNFs in VMs. We think that containers are going to be more secure, but VMs are the best way today. And then in the way that you run them, we've got some specific recommendations here, including things like running each VM as a specific Linux process and being able to limit a VM to specified CPU cores and RAM. When you look at a data center, one of the big benefits of cloud-centric technologies is being able to scale up and scale down and migrate around. But when you're looking out at the edge, in general, there's not a lot of that going on. So if a VM is scaling up or taking more resources, that could be normal, but there's also a very good chance that perhaps somebody's gotten in and taken it over the CPU for some bit mining or something, Bitcoin mining. You need to protect the hypervisor, which is the heart of the system, from rogue connections from the VMs. So there's ways you can do that, and what we suggest is being able to use security tokens so that once a VNF authenticates and connects, it has to pass this token down on every access. And then finally, providing support for VNF checksum validation so that if a VNF is corrupted, you can detect it and shut it down. So we talked now about the protections at the network and physical layer and at the virtualization layer. So that's really kind of the infrastructure that's contained within the universal CPE host. But that's not where it ends. If you're going to run this in a network, it has to be managed, which means there's management connections coming in from outside. That is yet another attack surface that we have to address. Fortunately, there's a lot of well-known tools that we can apply here, including things like multi-level CLI access. And you might say, well, why are we talking about CLI in this age of automation? Well, as much as we may not like CLIs, they exist. Network operators, technicians are going to use CLIs. That's a fact. So we have to make sure that we limit the access to the appropriate level based on the login. We need to prevent root OS logins locally. There's no reason that should be done. There's even some arguments that you never have any root OS logins, but that's a tough sell to an operator. They say, we need to get in the box. It's our box. We're going to run it. SSH for connectivity as opposed to older technologies like Telnet. And the usual things go along with that, like lockouts. Now, I mentioned here the embedded cloud. One of the things that we believe is very important in terms of realizing the benefits of cloud technologies is being able to use the tools that are successful in the cloud, and specifically OpenStack. OpenStack is a great tool. It's being deployed in a lot of cloud infrastructure. It is designed to work in the data center. If you try to run OpenStack in a mode where the controller's in the data center and the agents are out in the network, you introduce a whole bunch of problems, not the least of which are security problems. We have proposed a method where you push the OpenStack controller down into the node, and you now have a cloud in a box, or an embedded cloud. There's some difficulty in making that work, but once you make it work, what you have is the benefits of the cloud native control, because you've got the northbound interfaces of OpenStack, but you've solved the security issues by reducing the attack surfaces. So this is a very nice way to get the benefits of the cloud native architecture so that you can create these sophisticated service chains without introducing another security risk. Radius and TACACs are standard. We've heard a lot about the use of open source, and in a system like this, you've got a combination of open source along with enterprise proprietary code, in this case that we're providing. It's still necessary to apply all the usual tools. You've got to have the automated code inspection of the source code itself. You need to have the standard port scanning to make sure that some bit of code hasn't opened up a port for backdoor access. And then you've got to keep up with the security patches, and there's a variety of tools that do that. Again, none of this is rocket science, but what we have seen is that in many cases, these types of steps are omitted. Last piece is at the application and MANO, or management and orchestration layers. And what we're talking about here is that if you're talking about the system, we talk about a zero-touch deployment where perhaps a universal CPE device is shipped directly to the customer. How do you make sure that the right customer's got it, so that you're not letting some rogue user onto your network? This is a very interesting topic, and I'm going to be hosting a lunchtime debating table coming up here in a little bit. And this is what I'm going to be talking about, is how do you make sure that you can minimize the manual intervention required to turn up universal CPE, but maximize the security and make sure that you're not creating holes in your network. If you look at the orchestration side of it, you need to have a multi-tenant situation where you make changes to one user, it does not affect another user. You need to have the ability to segregate traffic, again, the usual role-based access encryption. I mentioned earlier that a very popular service chain is to combine SD-WAN with a firewall or UTM system, and that's because end customers, not the operator, but the end customer themselves, very often have done a lot of looking at firewalls and are very partial to a particular one. So being able to, as an operator, provide the customer with the SD-WAN solution they want and the firewall they want, and perhaps customer A gets a different combination than customer B, is very important. But the point here is that you need to be able to support that firewall so that you can, in addition to protecting the infrastructure, you're also protecting the applications. The other thing that is important here is that you've heard me talk about cloud native quite a bit, and our focus is a lot on the universal CPE at the customer prem. But if you think about it for a second, you realize that everything I've talked about here is all software-centric and applies equally to deploying in a cloud or data center. So in this world of multi-cloud, being able to take these types of steps, not only at the customer prem, not only at a public data center, not only at a private data center, but in all of those at the same time, lets you build this layer approach that spans the network. All right, the best part of any presentation, especially one right before lunch. In conclusion, these are the points that I hope you'll remember, and that is, first of all, we're seeing a ton of rollout of SD-WAN because it provides either cost reduction or sophisticated application control or all of the above. But in rolling this out, we need to do it in a cloud-native fashion so that we can get the benefits of multi-vendor, so we can get the benefits of service chaining, so we can get the benefits of dynamic services under user control, to be able to combine the best-of-breed functions. In doing that, we've made a more complicated system that means we have to take a more sophisticated approach to security, and specifically applying security at every layer. So that's the end of my slides, so I'm wrapping up a little bit later. Perhaps take one question or two if there's any. All right, otherwise I'll give you back a few minutes and we can hear from Nav from one of our partners.
Thank you.